on.
Yes, I'm
So
leaving. I just would like to add that it's very important thing that the understanding of the relevancy of the information we're getting. What I now, especially after like all the situation that happened to the country recently, it's very important to be more critical and understand the data we're getting. So, please, yes, the relevancy of the research is very important. I'm leaving. I'm giving you the time. Thank you.
all right, so I will start off with a little video I did previously. I made a channel about the actual research environment, and I'll play a small snippet of it just as an introduction, and then go through a little bit of what needs to be done to do better. So here.
About only 35% of research is statistically replicable. This is in most fields. How can it be? This research passed statistical analysis and the all-holy peer review. Now, according to a poll of 1,500 scientists, 70% of them had failed to replicate at least one other scientist's experiment, and 50% had failed to replicate one of their own experiments. In medicine, a 2012 study of preclinical medical cancer found that only 11% of those studies could be replicated. In psychology, a 2015 empirical study attempting to replicate 100 previous studies from 3 high-ranking psychology journals found overall that only 36% yielded statistical findings compared to 97% of the original studies. And these included 28 classic contemporary findings in psychology that are taught in textbooks. And overall, 14 of the 28 findings failed to replicate, despite massive sample sizes. A newer 2018 study sought to replicate 21 social and behavioral science papers from the most prestigious journals of nature and science. It was found that only 13 of the 21 could be successfully replicated. In neuroscience methods, specifically fMRI, studies can be overcomputed. This was left unaddressed in the field. That is, until some researchers proved their point by taking a dead fish and putting it into the fMRI and getting results that were statistically significant. This study was never published. Many findings like this aren't. But it did get an Ig Nobel Prize award. And a very recent study which proactively gave raw data to neuroscience fMRI groups to process and make conclusions about it found that the data was interpreted into different results depending on the group's processing. So this continues. A 2019 study which focuses on computer science showed that of the studies published in top conferences in computer science, on average, less than 40% of the articles were reproducible. In computer science, algorithms are often compared to each other. So repeatability and replicability are very important to reliably compare between algorithms. But human factors behind competition can make this difficult. The study above showed that of 18 algorithms, only 7 were repeatable with reasonable effort. The reasons for not being able to repeat can include not having the algorithm described or written well, or the test data not available. In a fierce, all-out competition, there may be a benefit for not having those available. How can the algorithm be criticized if it's not available? Other reasons are simply the claimed results of their algorithms was not obtained. But even in the repeatable articles which the results are obtained, much of the poor performance of compared algorithms were not replicable. When replicating the comparison algorithms did better than reported. In the study of the 18 papers, they did not find an algorithm that is better than what's already out there. The computer science findings are especially concerning since the field is endowed with some of the best resources, and the algorithms are implemented on a controlled computer environment where repeatability should be less of an issue.
I apologize. I forgot my mic was off. So this is a recording of a snippet of my video channel about updating research. It's all about why things like this are occurring, um, what can be done, how it happens in the past, is it still happening now, and what can be done to improve the situation. Now, sorry, I'm jumping between systems here. Here we go. Now, here, what I'd like to do is discuss a little bit about how to avoid the human factors and bad incentives that are ruining our world from research through economics and politics, and to enable true novelty through honest, facilitated reporting of honest science. Now, the core and basis of science is just one thing: it's repeatability. It is not about advertising, prestige, endowment, even peer review, honor, legacy, reputation, tenure, authority, rankings, money, publication indexes, politics. No. If we were following these, we would still be treating plague like they did back hundreds of years ago. Science is about repeatability, and repeatability is about statistics. And there is a lot of tools that have been created to analyze this, such as the bell curve, where experiments are designed so that, in theory, if the experimental test is a coin flip, that if it's repeated 95% of the time, if a result is significant, then it should occur 95% of the time, not by chance, only 5% by chance. This is the design of the study. So studies are repeated to show that the study result did not happen by chance. And so these are designed to be shown as 95%. Yet, when you try to repeat the studies, it's not 95%, it's lower than 35%, right? So there's a lot of stuff that's going on that is not quite true and honest. And this science is based on random sampling, taking at least a minimum of 30 samples, methods to calculate how powerful a study is, and analyzing the variables, whether continuous or discrete. Continuous are better for this sort of analysis. And there's all sorts of types of studies. So if someone wants to really understand whether they can believe a study, They need to look at the type of study. So randomized controls studies are best, cohort studies are less, so on and so forth. Moreover, there's a huge array of types of biases that can go into a study. And most of these biases are primarily human factors: what gets presented, what people remember, and so on. So easily a lot of these come into the studies and contribute to a lack of pure repeatability. So some of the take-home messages here is that every result, every finding or claim should be questioned based on repeatability. If someone says, well, sitting straight helps your mind function better, well, hopefully they can reference a study that did this in a statistical way. Moreover, trusted findings must be repeated over and over again through multiple independent studies. So, for example, when we're going to see a lot of feedback, brain feedback in the talks here. I'm a very big proponent of that in the neuroscience. One of the strongest findings is homeostatic plasticity, where the neurons that communicate, the input neurons that communicate to the output neurons, they then know what the output neurons are doing. There's this feedback. And that feedback has been found both when you stimulate, when you chemically change neurotransmitters, when you even change some of the genetics. The systems it's very important for them to set this backwards and forwards. And each paper that is showing the maintaining of this feedback is a repetition and another aspect of that property and phenomena. So then when you see a lot of papers repeating a similar type of finding, that suggests that finding is very strong and important. So the goal here is repeatable results, and they should be given open forums. There should not be pay to play or anything like that. Repetition, anything that is found with repetition should be given the priority with the repetition and the statistics. It's not about who has more money for paying the journals or advertising or anything like that. My background is neuroscience and computer science. I wanted to understand everything that's associated with the brain, with the philosophy that no field can completely cover what the brain is doing. And so therefore I studied everything from electrical engineering to study the signaling of the brain, neuroscience, computational neuroscience, so doing actual electrophysiology experiments and figuring out what can you pull out, cognitive experiments, seeing the reaction times, that gives you clues of what is the computations going in there, and medicine with a focus on neurology. And with that, I want to bring it back to the conference and the brain innovation.
Thank you, Dr. Tsvi. Yes, I believe it's very important to understand that a lot of information we're getting, it's not very often not relevant, and the thing is, it's applicable for pretty much any field in our life. It's not just about science. A lot of aspects